Hello everyone, welcome to today's class. This is Teacher Simon taking you through AS Pure Mathematics 1 paper 9709/13 for May June 2025, and this is part 2 from question 7 to 11. Question 7. A curve is such that dy dx is equal to 3x squared plus 10x minus 8, but find a set of values of x for which y decreases as x increases. If y decreases as x increases, then we shall have something like this. Probably it is going like that. X is increasing, but y is decreasing. Okay, that means here dy dx is less than 0. It's a negative. That's what it means. Okay, now we shall have 3x squared then plus 10x minus 8, then we say is less than what? 0. Now let us factorize this one here. Mod, then we have equation is 5, then quadratic is 3. Now we can put the 3 here, then the 10, then the negative 8. So we get 2 over 3 and then negative 4. 2 over 3 and then negative 4. So I'll skip some space here. X is equal to negative 4. Then the other one, x is equal to what? X is equal to 2 over 3. Yes, 2 out of 3. Now we need to get the factors from which these come. So when you cross multiply there, you will get the 3x, then bring the 2, then it is minus 2 here. And then when I bring this on this other side, it becomes a plus. So we shall have x then plus 4, then which is less than 0. I'm not going to write this because I'm not solving a quadratic equation, but we are solving a quadratic inequality. So we are supposed to look at regions. When I equate this one to 0, we have seen we get 2 over 3. When I equate this one to 0, we have seen that we get what? Negative 4. The coefficient of x squared here is a positive. Now, these are what we call critical regions, but this one is smaller than this one, okay? So we look at negative 4 and then the 2 over 3. So below this one, then in between, and then above. So which one satisfies this, okay? Now, what we are going to do is to consider first the coefficient of x squared here being positive. That means we are getting a U-shaped curve. You know, in quadratics, that's a U-shaped curve. Then these critical values are, we have negative 4, and then here we have 2 over 3. Now, the part that is above x-axis is always positive. You can see that y here is positive, and then y is negative below x-axis, not so? X is positive this way, and then negative this other side. Now, the part that is above x-axis is positive, so that means beyond 2 over 3 this way, you are going to get an x value, but then it will give you a y value this way, which is above x-axis, so it will be positive. You get it? Then also this way, when you get a value, let's say negative 5, negative 5 will find this curve going like that. You get it? And then you get a y value which is above x-axis. So meaning also less than this negative 4, we are seeing that this one is a negative, but in between these ones here, the negative 4 and then the 2 over 3, we are seeing, no, this one is a positive, pardon me here, and then here we shall see a negative because it is below x-axis. You see that? Now this negative, I mean less than 0, it means the negative region. So the region that we are taking is this one here. So I will then come here and write my answer as negative 4 less than x less than 2 over 3. As simple as that. Then part B, it is given that the maximum point of the curve has y coordinate 27. Find the equation of the curve. Since we are given dy dx, that means we can integrate this dy dx to get back our y, okay? So that means y is going to be the integral of 3x squared, then minus, I think it's a plus 10 of x, then minus 8, then dx. Okay, and here we are going to get 3x cubed over 3, so that one will give us x cubed. Okay, and then plus here, this will be 10x squared over 2, which will become 5x squared, then minus 8x. And then we need to put an arbitrary constant here, because we don't know that constant that disappeared when they differentiated, because you know that when you differentiate a constant, it disappears, not so? Okay, now to get this c here, we need to have one point on that curve that we can use. And they said the y coordinate here is 27. If the y coordinate is 27, then we need to find the x coordinate. Now what I'm going to do here, let me first extend this one here down. We know that for maximum point, point, this is a stationary point, not so? Then dy dx is equal to what? 0. So where is our dy dx? It is 3x squared, then plus 10x minus 8, which is equal to 0. Already we have seen that this is 3x minus 2, and then x plus 4, which is equal to 0. So meaning x is equal to 2 over 3, and then x here is equal to negative what? 4. Okay, now these two coordinates that I've gotten, one is supposed to give me the maximum, like the stationary point has to be maximum. So let me check. If I get the second derivative and you differentiate this one here, you will get 6x, then plus what? Plus 10. Now if I use x, let's say, is equal to negative 4, we shall have the sign of dy dx, I mean the second derivative, 6 times negative 4, that is negative 24, then plus 10. This one is giving us negative 14, which is less than 0. Hence what? Hence maximum. So that means when x is negative 4, that is where we are seeing the stationary point being what? Maximum. So therefore, I will take this x is equal to 4. You get it? So when I take x is equal to 4, then our y is the one that is going to be 27. You get it? So we are having negative 4 and then 27. So 27 is the value of y, then x is negative 4 cubed plus 5 times negative 4 squared minus 8 times negative 4, then plus c. Okay, so my c here is going to be 27. All the power of a negative is always a negative. So 4 cubed, negative 4 cubed will be negative 64, but when it crosses, it becomes a positive. So positive 64. And then square this one here, that will be 16 times 5, that is 80. So when it crosses, it's a negative. And then here, we are getting 32. When it crosses, it's a minus. Okay, so this means that our c is going to be 27 plus 64 minus 80 minus 32. We get negative 21. So negative 21. So meaning the equation of the curve is going to be y, which is equal to x power 3, then plus 5, x power 2, then minus 8 of x, and then minus 21. As simple as that. So here you needed to differentiate the second time, okay, and then you put these values. The one that gives you the negative answer for the second derivative is the one that has the maximum point. So you take that x coordinate, and then this is its y coordinate. Then you substitute in here to get the value of c. That was the trick. Question 8 is coming from a circular measure. The diagram shows a square ABCD where each side has the length 12 centimeters. Points E and F lie on the sides BC and CD respectively, and such that BE is a third of BC, DF is a third of DC. The arc EF is part of the circle with center A. The shaded region is bounded by the arc EF and the line segments EC and the FC. Part A, show that the size of the angle EAF is 0.9273 radians. Correct to 4 significant figures. Okay, now let's begin by finding BE. So BE is going to be a third. Where is BE? Is here, a third of what? BC. And BC, this being a square, this is equal to that, right? So times 12. This one will give us 4 centimeters. Not so. That means EC will be equal to 8 centimeters, because these two, when you add them, they give you what? They give you 12. And that is the same thing as DF. DF is going to be a third of 12, okay, which is also going to be 4 centimeters, meaning FC shall also be equal to 8 what? Centimeters. Now, they want us to find the size of the angle EAF. This is EA and then F. So this angle here. Okay. So they want us to find this angle here. Now, remember this whole thing is what? 90. Not so? If that is all 90, there is this angle here, alpha maybe. There is this angle here. I think it is also going to be the same, because if this is 90 and then 90, opposite is 3, adjacent is 12. Opposite is 3, adjacent is 12. So these two angles are equal. You get that? So using SOHCAHTOA, remember we can use SOHCAHTOA on a right angled triangle. So we can have tan then of alpha is equal to 4 over 12, opposite over adjacent, okay? And then for that case, alpha is then going to be the arctan of a third, right? Because this one simplifies to a third. So angle EAF is going to be equal to, it is what I've renamed as theta here, which is going to be, the whole of this is 90. So we have pi over 2, then minus this angle and this one, they are the same, right? So 2 of them, so minus twice the arctan of a third. Now when we put the whole of this in the calculator, do we get this? Remember, your calculator has to be in radians. If it is not, then you have to change it there. Now we have shift, then pi. We have pi over 2, then minus twice, then the arctan of a third. It gives us that 0.9273. 0.9273 radians. And that is to 4 significant what? Figures. Perfect. Then let's go to part B, find the perimeter of the shaded region. Now, perimeter of the shaded region, we shall need FC, then EC, but then we need this arc here. This arc here, FE. Okay, since it is this arc here, FE, then we need a radius here. You see that? So the radius of that arc is this AF or AE, but this is a right angle triangle. So using Pythagoras theorem, then we can get it, right? So I can say using Pythagoras theorem, then AF will be equal to the square root of 12 squared plus 4 squared. 144 plus 16, that is 160. So we shall have 160. Okay. Then from there, what else? Perimeter of shaded region. Remember, we are summing up the lengths around a given shape. So we have FC plus, what else? EC, then plus arc length FE. Okay, FE. Then FC is 8, then EC is also 8, then plus, remember this is the radius, and this is radius of the arc. Okay, so, and remember this one is r theta, so that radius is root of 160, and then the theta is 0.9273. So putting everything in the calculator, and then we write the answer to 3 significant figures, we shall get 8 plus 8, that is 16, then plus 0.9273 times the square root of 160. The answer becomes 27.7. 27.7 centimeters to 3 significant figures. As simple as that. Then part C, find the area of the shaded region. When we look at this one here, we shall get area of the whole square, not so, minus area of this triangle, minus area of this triangle, minus area of the sector. But since this triangle is the same as this one here, then I will say area of this square minus twice area of a triangle, then minus area of the sector. Okay, so we shall say here shaded area shall be equal to area of the square minus 2 times area of the triangle, then minus area of the sector. So what do we have as area of the square? That is 12 times 12, length times width, right? Then minus 2 times area of the triangle is a half times the base. I can take the base maybe to be the 12 and then the height 4. So we have 12 here, and then we have a 4. And then area of the sector is a half r squared theta, so a half. The r is this one here, r, then squared, then the theta is 0.9273. Okay. Now if I may, let's just simplify. This is 144, then minus this one, of course, goes 12 times 4, that will be 48, and then minus this will be 160, then divide by 2, that will be 80. Not so. So we shall have 80, then times 0.9273. So altogether, and to 3 significant figures, what do we get? 144 minus 48 minus 80 into 0.9273. This is 21.816. Okay, I can have 21.816, or you can write it as 21.8. 3 significant what? Figures that is that. Question 9 is coming from coordinate geometry. 3 points P, Q, and R have coordinates. These ones here, where K is a constant. It is given that the angle PRQ is a right angle, but assure that one of the possible values of K is 10 and find the other possible value. Okay, now I'm going to start by sketching. Let's say P is here, negative 13, 5. Then Q is 5, 1. So 5 has to be on the right. Okay. 5, then 1 is below 5, so it has to be down. Let's say Q is here, then 5, 1. And we also have R to 10. Show that one possible value is what? 10. Suppose I take this one here, 2 and 10. Then 2 is on the left of 5, right? And then 10, it is even above this 5. So probably R is around there. Okay. Now, I'm going to draw my triangle like this. So maybe put this one here. Then this one a little bit down here. And then this one just like that. So this is my P, which is negative 13, then 5. This is my Q, which is 5, 1. And then this is R, which is 2, K, or 10, whatever. Now, from here, actually, let me put K. But they have said 10, so just to be around there. Now, they said PRQ is a right angle. P, then to R, then to Q. So this is the angle, which is a right angle, 90 degrees. Now, these lines are perpendicular. So this one is perpendicular to this. And for perpendicular lines, what do you know? For perpendicular lines, the product of their gradients is always equal to negative what? 1. So let's look at the gradient of this one here. It is going to be K minus 1 out of 2 minus 5. Then times the gradient of this one is going to be K minus 5. Then 2 minus 13. So that will be 2, then plus 13. Not so. We equate to negative what? 1. And right from here, we can now multiply these two. So that is K minus 1. Then times K minus 5. I can even cross multiply. So this one is what? 15 times negative 3. So we have a negative 1 here. Then there is a 15. Then a negative 3. Like that. Not so? Now we open brackets here. We shall have K squared minus this times that is 5K. Then here we get minus K, and then here we get a positive 5. Then this one will be equal to what is 15 times 3? Isn't that 45? 45. So bring this one this side to form a quadratic. That will be K squared. This one will be minus 6K. And then 5 minus the 45, that one will be negative 40, which is equal to 0. Of course, here I have the sum is negative 6, then the product is 40. We can have 10 and 4. Then the negative will be on the 10. So K minus 10, I can say K, then plus 4. And then K minus 10, which is equal to 0. So for this case, we shall get K, which is equal to negative 4, and also K, which is equal to 10. So one of the values of K, you have seen it is 10, just as it is here. And then the other value of K is the other possible value. So the other possible value is this negative 4. You see that? Part B, it is now given that k is equal to 10. A circle passes through the points PQ and R. Find the equation of the tangent to the circle at R. Give your answer in this form, where A, B, and C are integers. Now, since this one is a right angle, okay, we have our circle here, and we have point R here, which is 210, like I showed you in the first part. Then P is around here, which is negative 13 R, no, negative 13.5. And then we shall have a Q, which is 5.1. Now, when we connect these ones here, they form a right angled triangle. Now, you should know that PQ, if this is 90 degrees, PQ is the diameter, okay? If you try to remember your circle theorems, okay? Angle in the semicircle is always equal to what? 90 degrees. So I'll say PQ is the diameter, of the circle, because angle in the semicircle is always 90 degrees. Okay, now we need to find the center of this circle. It is going to be the midpoint of what? PQ. So center of the circle shall be equal to the midpoint of PQ. So this one will be the average of the x coordinates, and then we also get the average of the y coordinates. So 5 plus 1, then out of 2. This one will give us 5 minus 13, that is a negative 8, divided by 2, that's a negative 4, and then 6 over 2, that one becomes a 3. That will be our center. And then from there, we need to find the radius. They told us actually to find the equation of the tangent at R. The equation of the tangent at R maybe is going to come like that tangent at R. So when we connect this to this one here, you should know that also the angle between the radius and tangent is always equal to 90 degrees. So they are perpendicular. Okay, now our center is negative 4, 3. So I'll find M1. I will say 10 minus 3, which is a 7, then out of 2 minus 4. And that one will give us what? 7 over 6? Yes, 7 over 6. And then our M2, which is going to be the gradient of the tangent at R. M2 is going to be equal to negative 1 over M1, which is this one here, because remember, for perpendicular lines, then M1 times M2 is always equal to negative 1. You get it? So therefore M2 is equal to negative 1 over this 7 over 6. Then we get this negative 6 over 7. Now using our y minus y1, which is equal to m into x minus x1. Remember, the coordinates we are using are those of R, 2, 10. So this will be y minus 10, which is equal to m, which is negative 6 over 7, then x minus 2. Now, since they told us this format here, okay, I will then just cross multiply. So when we cross multiply, this one will give us 7y minus 70, which is equal now negative 6. I should multiply with whatever is in brackets there. So we have negative 6, then plus 12. Now bring this on this side. Everything onto this side, we shall have 6x, then plus 7y, then minus the 70, then minus the 12, which is going to be equal to 0. So meaning our answer is going to be 6x, then plus 7y, and then this one will be minus 82, which is equal to 0. As simple as that. Question 10. A curve C has this equation here, but A find the coordinates of the stationary points. And you know for stationary points, dy dx is equal to what? 0, not so? So this will be power negative 1, then plus 2x minus 5. Okay. Our dy dx here is going to be, drop this one down, we shall get negative 9, then into 2x minus 5, then reduce the power by 1, then you enter inside and you differentiate here. That will give you a 2 using chain rule. Then differentiate here, we shall get a 2. Of course, this one disappears. Okay. Now, after that, like I said, for stationary points, dy dx is always equal to 0. So I'll get this one here. It will be 2, then minus, this will be 18. So I've written the positive first, then the negative last. Okay. Divide by, this is 2x minus 5 squared. Because using indices, that one can go down. Okay, then we equate to 0. That means we shall have 2, which is equal to 18 out of 2x minus 5 squared. When we cross multiply, and of course 2 will also go into this 9 times, not so? So we shall have 2x minus 5 squared, then shall be equal to 9. You get it? 2 goes here once, then here 9 times. Now, from there, we can bring this one this side. Or you can take the square root. So 2x minus 5. We can have 2x minus 5 will be equal to plus or minus 3. Because whenever you take the square root, you have a plus or minus. And then x here is going to be equal to, take the positive, then plus 5 divided by 2. Okay. Then you will get a 4 here. Then also x can be equal to, you take the minus 3, then add a 5, then divide by 2. And this one will give you a positive 1. So what will be y? They said we find the coordinates of the two stationary points. So we need to get y for each of the x coordinates. So this one will be 9 out of 2 times 4, then minus 5, and then plus, this will be 2 times 4, then minus 5. Okay, so what do we get here? And also here, y will be 9 out of 2 times 1 minus 5, then plus 2 times 1 minus 5. What do we get? Now, here, this is 8 minus 5, that is a 3. So 9 divided by 3, we get a 3 here. 3 plus 8, that is 11. 11 minus 5, isn't that a 6? We get a 6 here. Okay. Then here, this is negative 3. So 9 divided by negative 3, that's a negative 3. Negative 3 plus 2, what do you get? You get negative 1, not so? Then minus 5, you get negative 6. So we shall get negative 6 here. That means the coordinates of the stationary points, we have 4 and 6, then 1 and negative 6. As simple as that. Okay, then the other one, part B, they are saying find the second derivative and hence determine the nature of each of the stationary points. So we shall differentiate the second time. You remember dy dx. Up here we got negative 18 into 2x minus 5 power negative 2, then plus a 2. Yes? Then the second derivative is going to be, take this one down, it will multiply with the negative 18, then we get positive 36, and then 2x minus 5, then power negative 3, then times the derivative of what is here is a 2. And of course, when you differentiate this one, it disappears. Okay. Now we need to get the signs of the second derivative for each of the x values. So for x, which is equal to 4, that we got here. So what is the second derivative here? This one is going to be 36 times 2. You get 72, right? 72, then out of, this is 2, then times the 4 minus 5, then power 3. Now this is 8 minus 5, that is a 3. 3 cubed. Isn't that 27? Yes. 72 over 27, which is greater than 0. So that means that stationary point where x is equal to 4 is a maximum. I mean, is a minimum. Because when the second derivative is, if the sign is positive, then the nature is the minimum. You see that? Then for x is equal to 1, for x is equal to 1, the second derivative here is going to be again 72 divided by, this will be 2 times 1, which is a 2 minus 5, that will be a negative 3. Negative 3 cubed, or the power of a negative is always a negative, so here we are getting negative 72 out of 27, which is less than 0. That means that stationary point 1, negative 6 is a maximum point. Okay, because the second derivative is a negative. Part C, the curve C is transformed to the curve C1 using the translation of negative 3, 7, followed by reflection in the x-axis. Set the coordinates of the maximum point of C1. Now, we know that there's a translation, so you move 3 units to the left, then 7 units up, then a reflection in x-axis. If this is the, maybe you find the x-axis here, then this one will go down, maybe for that case, and what is going to change is the sign of y. X remains, but y changes the sign. Okay, now after that, that means since it is reflection, what was maximum then becomes the minimum, and then what was minimum becomes the maximum. Are we there? So we have, when we check backwards here, 4, 6 was the minimum. It is the minimum. Now we are going to transform this. You move it 3 units to the left, then 7 units up. It is still minimum. Okay, but now when you reflect it in x-axis, if it was like this, then it is going to appear like that. You get it? So now it becomes the maximum. So when we go back here, we shall have our 4, 6. Our 4, 6. Let's look at the translation here. This one will become 4 minus a 3, and then you have 6, then add on a 7. Then this one will give us 1, then 13. Okay, after the translation. Then here we are going to have a reflection in x-axis, and a reflection in x-axis, we have y, which is equal to negative f of x, because the y coordinate if I have something like this is the x coordinate, this is the y coordinate, and then you reflect it in x-axis, you are going to get this point here. X is still the same, but y is changing the sign. So that's why we say negative f of x, okay? Now, that means we change the sign of y, which is negative what? A third, I mean negative 13. So this will be our final answer. I said that what was minimum now is transformed to maximum. Okay, that's what we are meaning here. All right, then after reflection, what was minimum becomes what? The maximum. Now, Roman 2, find the equation of C1 in this format where A, B, C, D, and E are integers. Now, we have y, which is equal to 9 out of 2x, then plus 3. Was it 2x? Let me check. 2x minus 5, then 2x minus 5. So we have 2x minus 5, then plus 2x minus 5. Now, the first one, we are translating. Okay, we are translating using the vector negative. This is translation by vector. The vector is what? Negative 3 and then 7. So we shall have a 9 here. Then where there is x, when this one pops out and then comes into the function, then it changes the sign. So it's a positive 3. I've always shown these. Okay, so this one is x then plus 3, but there is a minus 5 here. And again, when you come to this one here, I will say x then plus 3, then minus the 5. You see that? Then this one will come here and then we just add it. Or also, if we are putting it on the side of y, then it would be y, then minus that 7. You see that? And then it goes this other side, and then it becomes a plus. So for the movement in the y, if it's a plus, you just add it here. If it's a minus, you just subtract it here. As simple as that. Okay, then we simplify this one. We shall have 9 out of, this will be 2x, then plus 6 minus 5, then plus, this is 2x plus 6, then minus the 5, then plus the 7. So finally, what do we get here? Okay, what do we get here? We are going to get y, which is going to be equal to 9 out of, this is 2x, then this will be a plus 1, and then this is plus 2x, then this will be a 1, then plus 7, that will be 8, not so. That will be a plus 8. So this is after the translation, okay? That is after the translation. Then now let's go to the reflection in x-axis. So here y then is equal to the negative fx, okay? So that means our y2 then is going to be equal to the negative of everything that we are having here. So that is that. So meaning our final answer, the equation of this C1 is going to be negative 9 out of 2x plus 1, then minus 2x minus 8. As simple as that. Question 11 is coming from functions. The function f is defined by f of x, which is equal to x squared plus 4ax plus a, for x being real, where a is a constant. The function g is such that the inverse of g is cube root of 2x minus 4 for x falling in the real values. Then part A, given that the range of f is f of x greater or equal to negative 33, find the possible values of a. Okay, now here, for part A, they said range of f is this one here. But if I get this x squared plus, how do we get the range for this quadratic function? X squared then plus 4ax plus a. This one here can be put in, we can express it in the completed square format. So we shall get this one divided by 2. You will get 2a. So x then plus 2a, bracket squared, then pop this one out, and then you square it, okay, like that. And then there is a plus a. The whole of this is this one here, okay. Now, some people may be asking themselves, why do I get this one and then I divide it by 2, put it here, then here? Okay, this is the reference. This is the reference here. Suppose you have, let's say, x plus b squared, and you expand this one, it is going to be x squared, then plus 2bx, then plus b squared. Are we there? Then I need one side to have that one there terms in x. So I will take this one, this other side. That means I will have x plus b squared, then minus b squared, which is equal to x squared, then plus 2bx. Now I want you to look at the coefficient of x here. Okay, it is 2b, but here we are having b. Okay, that b is got after we divide this one by 2, not so? So when we divide this one by 2, then it gives us this b. So I put it here, and I also put it here. So that's why I get the coefficient of x here. I divide it by 2, then I put it here and also here. You see that? Then this one simplified. We can have x plus 2a brackets squared. Then we have plus a. This one is going to be 4a squared. It will be a minus 4a squared. You see that? Now, this one here, since the coefficient of x squared is a positive 1, then it is a U-shaped curve. Are we there? Whose turning point is, get this one here, equate it to 0. That's negative 2a. And then the y coordinate is this one here, which is a minus 4a squared. Are we there? Now, since it is a U-shaped curve, then the range, okay, range of f, range of f is going to be, you can see that everything here, all values of y are going to be greater than this one here. It is the minimum, okay? We are seeing this as the minimum value of y here. So the rest are above. So that means the range of f is going to be f of x, then greater or equal to this a minus 4a squared. And here they say that the range of f is f of x greater or equal to negative 13. So that means I will just get this one here, the a minus 4a squared. Then I just equate it to negative 33. I think I said 13 here. It is 33, sorry. Okay, so I equate it to that one there. And then that is a quadratic that I can solve. Not so. So if I take everything to this other side, then because I want to make the coefficient of a squared positive, we shall have 4a squared. Then when a crosses, it will be a minus, then minus this 33, which is equal to 0. This is a quadratic equation in A. You see that? Now, after that, by the way, we don't need this. We just need what is here. All right. What do we need here? Let us solve this on a calculator. Mod, then 5, then 3 for quadratic, then we have 4, then -1, then -33, we get a 3, and then -11/4. So I leave space, I say x is equal to -11/4. Did I say x? It is a. Then a also is equal to what? To 3. Now show the examiner the attempt to solve this quadratic, so bring this one back. When you cross multiply, you will get 4a, and then when you take this on this other side, it gives you a positive. You see that? And then take this one this way, we shall get a, then -3, which is equal to 0. So the possible values of a are therefore -11/4, and then 3. Then part B, given instead that f(g)(g) of 0 is equal to 96, find the value of a. Now when we fall back here, they gave us the g inverse. We are going to do the same process, okay? When we are having a function and then we try to get its inverse, we interchange the x and y, then we make y the subject. So this time around, we have the inverse of a function, okay? Now, when we get, when we take this one back, then it will give us the what? The g, okay? All right, now, I'll say, first of all, the g inverse here is equal to the cube root of 2x. Is it -4? Let's check. Yes, -4. Now I will say let g of x be y. Okay, just come here and you say your y is equal to the same process we use when we are finding the what? The inverse. You interchange x and y. So here we shall have x, which is equal to the cube root of 2y minus 4. Now the next thing is to make y the subject, not so? So make y the subject. The first thing to do is to cube both sides. So we shall have x cubed, which is equal to now 2y minus 4. Now bring this one here. That will be x cubed, then plus 4 over 2. That will be our y. So this therefore implies that g of x is equal to x cubed plus 4 out of what? 2. Okay? Now, after this one here, we need to get the g of what? Of 0. G of 0 will therefore be equal to 0 cubed, then plus 4 over 2. This one will give us a 2. Then g of 0 then will be equal to g of what you have gotten out here, g of 2. Okay, so g of 2, then that will be 2 cubed plus 4 out of 2. 2 cubed is 8 plus 4, 12. Divide by 2, you get a 6, not so? Then f g of 0 is the same as saying f of 6. Are we there? Now, what is f? F is this one here. I can use this or this completed square format. Okay, you can use what you want, but better let me use this one here. F of x is equal to x squared plus 4ax, then plus a. So that means f of 6 is going to be equal to 6 squared, then plus 4a times 6, then plus a. This one is going to be simplified to, what do we have here? This is 24, then plus 1. That will be 25. So 25 of a, then plus 36. So this therefore implies that what we have gotten here, we shall equate it to 96. So 25 of A then plus 36 will be equal to 96. 25 of A shall be equal to 96 minus 36, and then 25 of A gives us 60. So that means our A then is going to be equal to 60 out of 25. By 5, you get 12. By 5, you get 5. So therefore, our A is equal to 12 out of 5. You can give it as a decimal, 2.4. So that has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.